Hello everyone, in this video we're going to be looking at logarithmic functions as inverses. A logarithmic function is the inverse of an exponential function. To evaluate logarithmic expressions, use the fact that x is equal to the logarithm base b of y is the same as y is equal to b raised to x. Keep in mind that x log y is another way of writing x is equal to the logarithm of base 10 of y. So let's look at logarithmic functions as inverses. Now look at your exponential function. In your exponential function y, your y in here is actually called your output. But in logarithmic function, it is going to be your input. That makes them inverse. Now look at the value of x. In here, your x in exponential is actually your input. While in your logarithmic, it now becomes your output. So they are actually inverse. The only thing that remains its position is the b, the base. The base will always be the same. Whatever your base in your exponential should also be the same base in your logarithmic. So I hope this is a very easy understanding of why logarithmic functions and exponential functions are actually both inverse functions. Let's look at this one. What is the logarithmic form of 6 cubed is equal to 216? Now let's remember something in here. We say that to execute exponential to logarithmic, let's look at your exponential here. This is going to be your y is equal to b raised to x, and we're going to execute it as a logarithmic form. So that's going to be x is equal to logarithms of base b y. Okay, given that fact, let's now convert it. So we know that 6 cubed is equal to 216 is actually in its exponential form. So to get the logarithmic form of this, let's get the x. What is our x in here? It's the 3. 3 is equal to the logarithms. What is our base? 6. And what is our y? It's 216. So this is how you're going to convert exponential to logarithmic form. Letter B. What is the exponential form of 4 equals logarithm of base 5, 625? Now, it's very obvious that this is in its logarithm form. It's x is equal to log base b equals y, and we are asked to change it into its exponential form, which is y is equal to b raised to x. Okay, given that fact, let's now transform it. So our y here is 625, our base is 5, and our exponent is going to be 4. Okay, so that's how easy to actually change from exponential form to logarithmic and vice versa. Write each equation in logarithmic form. Okay, so let's do this one. 8 cubed is equal to 512. That's gonna give you the logarithm. Our base is 8, and then our y is 512 is equal to 3. Okay. Next, it's going to be 1/3 raised to negative 2 is equal to 9. Okay, so we're going to form into our base here is going to be 1/3, and then our y is 9, and then our exponent is going to be negative 2. So that's how you're going to transform it. Number 3, 100 raised to 1/2 is equal to 10. Now logarithm, our base here is 100, and our y is 10 is equal to 1/2. Number 4, that's going to give you the logarithm. Our base here is 5. 1/125 is equal to negative 3. Last but not the least, here our base is going to give you 24/01. 7 is equal to 1/4. Write each equation in exponential form. So let's do this one. First, let's look at the base. The base is 5, and the input should be 3 is equal to 125. Next, this is going to be our base is 13 square is equal to 169. Next here, the base is 4. Negative 1 is equal to 1 over 4. Next, the base is 8 raised to 2 over 3 is equal to 4. Last but not the least, your basis is 100 raised to negative 1/2 is equal to 1 over 10. Let's evaluate each expressions. Log base 12 of 144, so we know that 12 square is equal to 144. Therefore, this is going to be 2. Log base 2 of 1 over 32. Now we know 1 over 32 is going to be written the same as 2 raised to 5. And if you're going to get it to its exponential form, that's going to give you a negative exponent, which is negative 5. Next, log base 2, 16. So let's see, 16 can be written in base of 2 also. So 16, if I'm going to multiply it 4 times, then I'm going to exactly get 16. Therefore, log base to 16 is equal to 4. The next one is log base 9, 243. Now let's look at this one. 9 raised to x is equal to 243. Now I can factor 9. Actually, 9 can be represented as 3 square raised to x. And 243 can also be on the base of 3. If I'm going to multiply this 3 with, let's say, 5 times, then I can also get this one. So if you're going to get now your value of x in here, 2x is equal to 5. X now is going to give you 2 over 5. So that's going to be your answer, 2 over 5. Okay, the last one, number 5, log base 3 of 181. Now let's look at it this way. The base is 3 and we don't know the value of x in there, and 1 over 81. But we can also use the base of 3 for 81. And that's going to give you 3. If you're going to multiply it 4 times, it's going to be 3 raised to 4. Now, 1 over 3 raised to 4 is the same also in its exponential form as 3 raised to negative 4. Since they have the same basis already, then here the x is going to give you negative 4. Therefore, your answer here is negative 4. Okay, so this is how you're going to evaluate these types of expressions without even having to use your calculators. So this is all for now on this lesson on logarithmic functions as inverses. If you find this video very helpful, subscribe and share. Thank you very much.